Hello everyone, I am Dhruv and today I'll be presenting you our solution in the AI Innovation Hackathon done by Yamaha. So in this hackathon, we used a self-supervised segmenter to solve the current problem. So what is our problem statement is we have to train a self-supervised learning model for efficiency binary segmentation of histology images. So here we are given an image and we have to segment out these cells as a binary mask, and we have to also create a user-friendly web page for it. So these are our tasks. So first we have to do a pre-text training, which is done to ensure that we can get a better latent space representation of our image. Then we have to do the segmentation, and then we have to make the masks. And then the final step is to create a user-friendly web page. So let's describe our data set first. So we have our data set with and without segmentation mask. So there are 3842 unlabeled images and 640 labeled images. So the image looks like this, and then its corresponding segmentation mask looks like this. So we are trying to basically segment out the nuclei, and all the images are RGB with 256 cross 256 cross 3 size. And the labels are of grayscale with 256 cross 256 cross 1. So first, the trial model which we used was a unit-based customized encoder decoder model, which was pre-trained on basically a very high amount of pre-text conditions. So we merged all the pre-text conditions and we tried to recreate the original image. That's how we trained the encoder part of it, and then we fine-tuned the encoder decoder part using the limited amount of samples available. So we were able to get a dice coefficient of 0.81 and the corresponding Jaccard coefficient of 0.70, and we have an inference time of 50 seconds per 100 images. Then what we thought of that was, like, we were getting very good results by using a single unit, so why not use two units? So while analyzing the output, we saw that there were a lot of tiny noise patches which could be enhanced. So we used another unit based architecture which was trained to learn these tiny patches and remove them. So by doing this, we had an accuracy score of 0.83 as a dice coefficient and the Jaccard index as 0.72, which was the improvement from the last. So here let's try to visualize this. So here you can see in this blue area, this is our original mask which we want to create, and this is the mask which was predicted by our first model. So here we can see that in this blue region there is a dot which should not be there. So when we applied our sequential model, this dot was gone. So this model was able to get this, know that this was a noise and then remove it. So this was our sequential model. Then what we did was, so for our innovation, what we did was we trained three pretext tasks. So first was our colorize. So we decolorized the image into grayscale and then we tried to recolorize it. And here we did some patch masking, and then here we used VGG16 base unit. And then we got a three channeled output and then we unioned it to get our final result. And then on this final results we applied our or the previous sequential model to get the results even better. So while doing this, we were able to get a dice coefficient of 0.8386 and the Jaccard index of 0.7230. And then when we applied the sequential model to it, the accuracy increased a little bit, so which is expected. So the further work which we can do is, like, we don't just want to union the output, we want to make it like a unit architecture which can try to learn the model weights for all the predicted outputs and make an ensemble out of it. Now the web app demo will be shown by Paras. Over to you, Paras.
Hello, this is a demo of the web page for the HistologyNet project which we have created. In this, there's a instructions tab for easy usage of the web page so that one can understand from here. Then there is in the sidebar there is some information about the project and the GitHub code for this web page. Now this is the main place where one can browse files. One can browse any number of files here, and for example I have added five jpeg images, and one can directly go for segmentation, generating the segmentation masks for these images, or he or she can choose to enhance or edit these images. So in the enhance edit option there are two options. One is the cropping and other is the rotation thing. So for example here I have from the drop down chosen this image 113.jpg. Here I am just cropping it to some random rectangle, and there is some rotation that I've applied to this this image. I'll apply the edits. Similarly, we can apply edits for other images as well. For now, I'll just go with submitting this image. So all the images are being submitted. The model will generate segmentation masks for all these images. So we can see the results here. These are the original images, and these are the segmentation masks created for them. And there is an option of visualize better, where one can actually compare the results of the segmentation of the model of segmentation. For example, with the help of slider, I'm showing how these red colored cells are being segmented out here. Similarly for others as well. So apart from that, there is one more functionality. When we go back to the normal view, there is an option of downloading the images as well. So when one downloads, this will create a zip file consisting of two folders, one for the original images and other for the masks generated. While downloading, it will preserve the names of the files as well. So whatever name the user has submitted, that would be returned back after downloading as well. So thank you.